Hello friends. Today the topic which we are going to cover in this session is solution of simultaneous linear equations. So if we talk about this topic, then we can say that this topic, simultaneous linear equation, this is one of the most important application of matrices. So when we are going to write, you can consider this simultaneous equations as we can write x plus 2y is equals to 4 and 3x plus 5y is equals to 1. So here you can see this is 1x, because if nothing is there then this is 1. This 1 and 3, these are known as the coefficients of x, and this 2 and 5, they are known as the coefficients of y. And here you can see that if these are the coefficients, then these values 4 and 1, they are basically the constant values. Okay, they are the constant values. So we can get the coefficients as well as the constant values. Fine. So here in this, what we will do, the matrices, they are multiplied together so that you are realize that these can be written in matrix form, as we can say here, like A is equals to 1, 2, 3 and 5. Okay, so this is my first matrix. Second is X is equals to X and Y, and B is equals to 4 and 1. Okay, so this 1 is the coefficient of x, this 3 is the coefficient of x, this 2 is the coefficient of y, and this 5 is the coefficient of this second equation. And xy means we have two you can say variables which are multiplied with these coefficients, and b, the values which are given on this right hand side, they are termed under the they are termed as 4 and 1. So what we have? We have Ax is equals to B, right? So this is the matrix form of simultaneous equations. Here, the only unknowns in the matrix, they are X. They are not known to us, right? And as you can see here that A and B, they are already known. A here is called the matrix of coefficients. Now, if Ax is equals to B, this is given to me, right? What we will do? We will multiply both sides with, we will multiply both sides with A inverse. What we will get? A inverse into Ax is equals to A inverse into B. So we already know this thing that A inverse into A is equals to 1. So this is 1x is equals to A inverse B, means x is equals to A inverse B. Okay. So we can say here that if Ax is equals to B, then x is equals to A inverse B. So this results give us a method of solving simultaneous equation. All we need to do is write them in matrix form, calculate the inverse of the matrix of coefficient, and finally perform a matrix multiplication. So point here is how we will do this thing. So in order to solve this linear equations, we have two methods. First is Martin's rule, and second is Cramer's rule. So under Martin's rule, what we will do is, first of all, we will find the value of determinant. Second point is we have to calculate cofactors. Third is cofactor matrix is framed. Fourth is adjoint is calculated. And fifth is inverse is calculated by dividing the value of adjoint with determinant, right? So today we are going to cover this point, this Martin's rule. Fine. Now see, we will get results only if the A matrix is non-singular matrix. is non-singular matrix, means determinant is not equals to 0. Now what if we have determinant equals to 0? So this shows that the system of equations have infinite solutions, and here the system of equation have no solution. Okay. Now how to proceed with this? Let us solve this with the help of a practical example. Now consider this equation. We have a matrix, let's say A, okay, in which the 3 rows are given and 3 columns are given, means this is a matrix of order 3 by 3. Okay. So consider the equation Ax is equals to B. So here A is 1, 3, 3, 1, 4, 3, 1, 3 and 4. So this is my A, and if we consider x, let's suppose x as x1, x2 and x3, and b we will suppose it as b1, b2 and b3. Okay. So or we can write it in this form, ax collectively as x1 plus 3x2 plus 3x3, then x1 plus 4x2 plus 3x3, then x1 plus 3x2 plus 4x3. So this will give me AX matrix, and this is equals to, I'll write here as B1, B2 and B3. Okay. So if to write it in the form of equations, what I will do, I will write it as x1 plus 3x2 plus 3x3 equals to B1, then x1 plus 4x2 plus 3x3 is equals to B2, then x1 plus 3x2 plus 4x3 is equals to B3. So I will get 3 equations. Okay. So I will get 3 equations. Now we have to solve x1, x2 and x3. So this I have already explained you in the previous video, that how to solve this x1 and x2 and x3. So what values I will get? X1 is equals to 7b1 minus 3b2 minus 3b3. X2 is equals to minus b1 plus b2, and x3 is equals to minus b1 plus b3. So these values I will get from by solving these linear equations with the help of inverse method. So now I will write it in another form. See, these are my 3 values. Okay. So what I will do, I will write it in as x is equals to A inverse B, right? So x is my x1, x2 and x3. So this is my values of x is equals to A inverse B. What is this? This is um, 7b1 minus 3b2 minus 3b3, then minus b1 if I have b2, so plus b2, but I don't have b3, so I will write 0 b3. Okay. Then I have b1 minus b1, but I don't have b2, so I will write 0 b2 and b3, so plus 1 b3. So where it is simple, a single value b1 is given, so I will write it as 1 b2. Okay. So this way I will able to derive my matrix, or I can write it in this form also: 7 minus 3 minus 3, 1 1 0, this is minus 1, minus 1 0 and 1. So this is my A inverse. So this is the value of A inverse, and B is what I have is B1, B2 and B3. So this is my value of B. So this we can say we get A inverse into B. So ultimately I will get the value of A inverse as 7 minus 3 and minus 3 minus 1 1 and 0 minus 1 0 and 1. So this is the value of my A inverse with the help of Martin's rule. Okay, so you can see here when we will solve this question, you will find that the determinant is equals to non-zero. Only then we will able to find these values. But if the determinant is equals to 0, then we have to go for the further processes, and that I will explain you in next example. Thank you.